Hi, I'm Michael Woods, Chief Scientist at the Asian Turfgrass Center, and this is another ATC Doublecut. In this episode, I'm going to take a look at something that I wrote about on the blog about expressing soil organic matter as a mass or as a volume. And the standard way to do this when doing soil testing is to express the organic matter as a mass. So when we're talking about the humus in the soil, something down to a say 4-inch or 10 centimeter depth, where in a golf course putting green, it would be typical to have about 1.5, 1.8, 2% organic matter, something like that. That is the soil organic matter that is expressed on a mass basis, meaning there is, if the soil organic matter was 2%, what that means on a mass basis is 2% organic matter per mass of soil, 20 grams of organic matter per 1 kilogram of soil. And it's different on a volume basis, and I think it's interesting to make that calculation. And on the blog, I made some calculations and put a pretty chart up there, which you can have a look at if you go to the website, asianturfgrass.com. And in the show notes here in the description, I put a direct link to this particular blog post so you can go check out this chart yourself. Because what happens, and it's interesting to note, is that the organic matter by volume in the soil increases a lot faster than it does by mass. So if you have a soil that is 5% organic matter by mass, the organic matter by volume is already 27%. And this, of course, is also related to the OM246 testing. OM246 testing being organic matter at the 2, and then the 2 to 4, and then the 4 to 6 centimeter depths below the surface. And when we're looking at those types of organic material, the total organic material, this is not the soil organic matter anymore, because we're not screening off any of the undecomposed living and dead plant material. Instead, we're measuring everything and expressing that on a mass basis. The standard way to do it is express it as the weight of organic matter per weight of soil. Multiply that by 100. There's your percentage. So 5% organic matter by mass is 50 grams of organic material in a total soil weight of 1 kilogram. And when we convert that to volume, now expressing that as the volume of organic matter per the volume of soil, it now goes up to 27%. And the reason for this big difference, which may not be intuitive at first, the reason for the difference is the different bulk density between organic material and sand. Now, sand has a bulk density of about 1.5 grams per cubic centimeter. I have a handful of organic matter here, and this is some simulated thatch that I've got for an experiment that I'm doing. And this is in a Ziploc bag, and I guess this is about a liter of material, and it weighs almost nothing. Now, it's not compressed, but it weighs, I don't know, maybe 100 grams or something. And if that was that volume of sand, that would weigh 1.5 kilograms. That would weigh 3 pounds. And so there's a huge difference in the mass of soil material, the mineral soil material, and the organic soil material. There's a huge difference in mass, and that's the difference in mass per the same volume. So as the bulk densities differ, that is why you get these striking differences in percentages. And of course, that has a big implication to things like infiltration rate and water holding capacity of the soil, because as the organic matter starts occupying more and more volume of the soil, eventually you end up with a sponge instead of a soil. And so when you get the organic matter by mass, the organic material by mass up to 12.5%, that's where the volume of organic matter exceeds 50%. Now, this is based on bulk density of sand being 1.56 grams per cubic centimeter, and the bulk density of organic material being 0.22 grams per cubic centimeter. That may not be exactly what they are, but this shows how the relationship works out. So that's something that I think is fascinating to consider, because especially as I've been doing this OM246 testing and looking at soil organic material in the top 2 centimeters of a root zone at 6, 7, 8, 12, 15% organic material by mass, I wondered what it was by volume. So if you've got 12.5% organic matter by mass, and in fact, I just did a OM246 report yesterday in which the average organic material in the top 2 centimeters was about 12%. And that it seems relatively high. It's a bit higher than average, but you can still have good grass at that level. But if you want to express what that would be as a volume, you can expect that the organic material as a volume, when the mass is 12% organic matter, the organic matter as a volume of organic matter per volume of soil would be about 50%. About half of that volume would be occupied by organic material. Thanks for joining me for this episode of the ATC Doublecut, where I take a second look at topics that I've written about on the blog. This one was about organic material by mass and organic material by volume in the soil, and how those are not the same thing. There's a cool chart about it on my blog at asianturfgrass.com. You can see that at the website, where I've put the direct link to that in the description. All right. Thanks for listening and watching, and I will talk to you next time with another new episode about turfgrass topics that I've written about on the blog. Thanks.